Controlled traffic farming (CTF) is a management tool which is used to reduce the damage to soils caused by heavier repeated agricultural machinery passes on the land. This damage and its negative consequences have been well documented and include increased fuel use, poor seedbeds, reduced crop yields and poor soil function in terms of water infiltration, drainage and greenhouse gas mitigation. Controlled traffic farming is a system which confines all machinery loads to the least possible area of permanent traffic lanes. Current farming systems allow machines to run at random over the land, compacting around 75% of the area within one season and at least the whole area by the second season. Soils don't recover quickly, taking as much as a few years. A proper CTF system, on the other hand, can reduce tracking to just 15%, and this is always in the same place. CTF is a tool. It does not include a prescription for tillage, although most growers adopting CTF use little or none because soil structure does not need to be repaired. The permanent traffic lanes are normally parallel to each other, and this is the most efficient way of achieving CTF. But the definition does not preclude tracking at an angle. The permanent traffic lanes may be cropped or non-cropped depending on a wide range of variables and local constraints. Achieving controlled traffic farming. Controlled traffic farming can be achieved on any scale, but to get tracked areas to the minimum possible, there are three requirements. To match implement widths so that adjacent passes are in the same place for all machines working in the field. To match the track widths, the distance between wheel centers on the same axle of all field machinery. To keep machines in exactly the same place year in year out. Matching implement widths is a case of forward planning, or making sure that if anything doesn't match now, its replacement will. It's also the case that the wider the implements are, the less will be the tracked area. Growers often find they can use wider machines because without soil damage, they are easier to pull, and in the case of cultivators, most likely don't need to work anywhere near as deep. Matching track widths is more difficult because grain harvesters often come with a track of 3 meters or more, and matching to these would make all machines very wide and often impractical to use on a daily basis. Matching to the harvester track works well in Australia, where properties are often remote. There is plenty of space and road travel may not be too extensive. In other parts to the world, including most of Europe, alternatives have been found. These may not be quite as efficient in minimizing the tracked area, but achieving less than 20% is still perfectly feasible. In controlled traffic farming systems for vegetable cropping, track widths vary between 1.83 meters, the 72 inches imperial standard, to customized systems of perhaps 3.2 meters or more. Road transport with these wide systems can be difficult, but their use in the Netherlands and Denmark is increasing, and growers accept the constraints because of the advantages that the systems bring. Keeping machines in exactly the same place is most easily achieved with a satellite guidance system, based on an RTK correction signal and autosteer. Only the RTK system can guarantee to keep vehicles in the same place year in year out, and it also achieves the highest pass-to-pass accuracy of around ±2 centimeters. Guidance systems have many other advantages, and once a system of this nature has been adopted, the natural progression is to move to controlled traffic farming. The generic advantages of guidance include much reduced overlap between passes of machines, particularly of wide cultivators, which may overlap by around 10%. Although planters and drills use physical markers to match up between one pass and the next, cumulative errors can be large, and non-crop tracks created by these machines. Tramlines for chemical applications can often have an overlap of 5%. The implications of this are significant because tramlines are used for all chemical applications. A 5% overlap wastes the equivalent in increasingly expensive materials and through overdosing damages crops and could lead to extra runoff and diffuse pollution. Advantages. These are manifest and new benefits are regularly being reported. But the main advantages are improved crop yields, particularly in seasons with extreme dry or wet, lower inputs for crop establishment, which reduce fuel use, reduce power demand meaning smaller tractors to do the same job, improved timeliness of operations, better soil health and function, which improves soil porosity meaning there is more space for water and air, improves water infiltration which reduces the potential for soil erosion and increases water availability to the crop, improves drainage which avoids waterlogging and the potential for nitrous oxide and methane emissions and methane oxidation, improves crop rooting and the efficiency of nutrient uptake, leading to less waste and potential for environmental pollution, improves field access, particularly when soil moisture is high. Field operations are often needed in less than ideal conditions and when carried out, can cause extensive damage. Controlled traffic farming provides a firmer base for these operations, the permanent tracks, and constrains the damage to narrow strips. Disadvantages. More discipline is required in the field, and can increase journey times when removing large volumes of material, such as sugar beet or potatoes. There is greater reliance on sophisticated technology in the form of satellite guidance and autosteer. If a machine is in a state of disrepair, an exact replacement with a matching track or implement width may not be available. The cutting width of grain harvesters, for example, seldom match up to cultivator or drill widths. More demand and time could solve this issue. Once a field has been laid out with a controlled traffic farming system, it is not advantageous to change it. However, it is not impossible because only around 20% of the field may be compacted and the position of these strips is known. Future. Although controlled traffic farming is still in its infancy as far as adoption is concerned, partially because the enabling technology of satellite guidance is still relatively new, there is a better engineering solution that would reduce tracked areas to less than 10%. This is not a recent concept, having been pioneered by Alexander Halkett in the 1850s and David Dowler in the 1970s. But the concept of a wide-span vehicle is becoming increasingly attractive because of the other advantages it brings. The concept is described in detail at Controlled Traffic Farming Europe's wide-span page and achieves the low tracked area by virtue of using one of the same wheel tracks on adjacent passes. The system also reduces reliance on satellite technology because the guiding wheel track for the next pass is automatically laid down, with implements mostly contained within its wheel track. Part-width operations, for example plowing or root crop harvesting, are perfectly feasible, whereas with existing tractor systems they are not. It is speculated that once the widespread advantages of CTF have been discovered, the constraints of existing machines will lead to development of this far more sophisticated, efficient and appropriate technology. CTF Europe. CTF Solutions. Controlled Traffic Footprint Choices. Australian Controlled Traffic Farming Association. ACTFA.